Okay, folks, so we're talking about resistors here. So the two different types here, the wire wound and the carbon composite. So the wire wound, basically longer and thinner wires, we were saying, will increase the resistance, whereas the carbon, excuse me, composite will vary by the diameter and the composition. Okay, so if we want to test voltage or current, we can actually use just a multimeter, right? So of course the voltage will basically be measured by the potential difference, and the amps are just the speed of the current or rate of flow of the current. So smaller currents can be measured using galvanometers, but typically we'll use a multimeter if we want to measure any one of those three. Okay, so if we look at analyzing and building electrical circuits here. So here's just a key that's used when we look at the schematic of a circuit diagram. So some of these you're probably already familiar with. So cells are slightly different than batteries because, of course, batteries are made up of cells. Incandescent lamps here are some that you'll see, switches, voltmeter, ammeters, and so on. Okay, so we have just a handful of components to a circuit. So remember, we need a source, which would be basically a power source for our voltage. Okay, so a source for our electrons. So we need a conductor, and that's going to be our wiring. Switching mechanism is not essential, but typically we'll have those. Okay, so that will control the flow of current. So we can turn it on or off, direct it to different parts of the circuit, and so on. And then, as we were saying, a load will be whatever's using up that current. So that could be a lamp, that could be a buzzer, could be a small motor. So various items could be the load. So if we have a circuit which is open, it's said to be off. So right now this is open and it's off. So if we want that to be closed and on, we just have to push this switch. So this right here would be our source. This is our switch. This is our circuit. And this would be our load. Okay. So if we look at a toy bulldozer, it has two loads. So it has a motor and a bulb. So we have two 1.5 volt cells that act as an energy source, and a switching mechanism connects to 4 wires. Okay, so you can make an attempt to label these. So we do have two different types of circuits, and one set is the series and one set is the parallel. So two basic ways to connect circuit components. Okay, so in a series circuit, so there's only one pathway. Okay, so if there's a break in the circuit, the whole circuit cannot function. So if we add some components to this, it increases the total resistance in that circuit and decreases the current. So as we add more lights, it will get dimmer because more of that current is getting used up. So consider each load almost like a type of resistor, right? So as you can see that there are two disadvantages to the series circuit. So however, in a parallel circuit, we have multiple pathways for the current to flow. So components in these can have their own pathway to a current source, right? So this right here will be its own circuit. This right here would be its own circuit. This right here would be its own circuit as well. Okay, so if we have a break in a section, so for example, there's a break right here where this resistor is, then that's not going to affect this second circuit, and it's not going to affect this third circuit. Okay, So adding resistors in parallel will decrease the total resistance of the circuit as well, right? So we can have current going through just this one load here, or we can have current going through this load right here, okay? So some of the applications of series and parallel circuits, we have house wiring, which will use parallel circuits. Because of course, if we're adding additional lights or adding additional appliances, we don't really want to see a decrease in the amount of current going to those items. And this is especially true if we have high resistant, using appliances that have high resistance. So for example, like coffee makers, or electric kettles and so on will have high resistance, as will hair dryers. So we can also have things that are made up of transistors and resistors. These are microcircuits, and they're extremely small scale. And then, of course, we can have microcircuits that are integrated, and transistors will be used with these. And basically, the transistors, which are very small switches in this case. Okay. So there is a circuit simulator to help you gain a little bit of a better understanding of how circuits are put together and how they work. As well, in your textbook, there's a little bit more on this from page 311 to the end here, which is page 315. So have a look there and let me know if you have any questions about that.